Hello again, welcome to another video. This one's going to be about diffraction of waves. Today the outcomes are that you should be able to give a definition of diffraction, state that the longer the wavelength, the more a wave diffracts, draw the diffraction pattern for a wave passing around an obstacle, and be able to draw the diffraction pattern for a wave passing through a gap. So what is diffraction? In a nutshell, it's when waves bend around an obstacle. All waves diffract: sound, water, light. Here we see waves moving towards an obstacle, and you can see that the waves are blocked by the obstacle, but as they pass beyond it, they tend to fill in the gap behind the obstacle. This is diffraction. The area behind the obstacle that the waves don't enter is called a geometric shadow. Notice that the wavelength here is quite short, and the waves don't really bend much behind the obstacle. They find it difficult to diffract. So what happens when we pick waves with a longer wavelength? Well, we see that the waves fill the gap much more quickly. There's a smaller geometric shadow, and this is a tendency that all waves have. The longer the wavelength, the easier they find it to diffract, the easier they find it to bend behind the obstacle. Now we have waves passing through a gap. Again, you can see the waves pass through the gap and they're blocked by the obstacle on the top and the bottom. But as they pass through the gap, they have a tendency to spread out and fill the area behind the obstacles again. This is diffraction. So at National 5, you're going to be required to draw these wave diagrams. A really typical diagram is like the one we have here, where we have waves leading up to an obstacle, and you will be asked to complete the diagram as the waves pass beyond the obstacle. So you'll complete the diagram by drawing something like this. There's a few things that I need to point out to you though. Notice that the waves after the obstacle have the same wavelength as the waves leading up to the obstacle. A lot of times I see pupils drawing waves with different wavelengths when it's passed by the obstacle. This is wrong. The waves need to be drawn with a consistent wavelength. Notice that the waves after passing the obstacle have nice straight lines, but with a little bend at the bottom to show them just moving into that area behind the obstacle. You'll also be expected to draw this diagram here, where you'll have the waves leading up to a gap, and you'll be expected to draw the waves as they pass through the gap. Again, nice straight lines with curves at the top and the bottom to show the wave moving into the area behind the obstacles. So to recap, when you're answering exam questions, make sure you've got a consistent wavelength in your diagrams. Nice straight lines, make sure you draw them with a ruler. And a slight curve at the end of each wave to show it moving into the gap. I can't stress enough that a neat diagram is essential. If you make a half-assed attempt at drawing a diagram, the markers will mark you wrong. We'll have a quick look at the 2019 exam paper example. It's from the multiple choice. Which of the following diagrams shows the diffraction of water waves as they pass between the two walls? So this is the gap diagram. Just a reminder for what we should be looking for: nice consistent wavelength before and after passing through the gap, nice straight lines, and a little curve at the end of each line showing it moving into the area behind each wall. Take a couple of seconds, decide whether it's A, B, C, D or E, and the answer is D. A doesn't show any curving in behind the wall, it shows no diffraction at all. B shows curved waves, it doesn't show straight lines. C, we see that the wavelength after passing through the gap is much smaller than the waves before the gap. And with E, we see the opposite, where the wavelength is much larger after the gap than it was before the gap. D is your answer. Another quick example from the 2017 past paper. Waves travel towards the entrance of the harbour as shown, and you've got to complete the diagram to show the pattern of the wave crests inside the harbour. So again, nice straight lines passing through the gap, a consistent wavelength, and a slight curve to show the diffraction in behind the gap behind the harbour wall. Looking at the marking scheme from the paper, it's worth 2 marks, and you'll get 1 mark for showing the diffraction of the waves into the shadow region, and 1 of those marks showing straight sections in the middle and consistent wavelengths before and after the gap. So, to recap the outcomes from this video lesson, a definition of diffraction. Diffraction is when waves bend around an obstacle. Please remember that the longer the wavelength, the more a wave diffracts, or the easier it finds it to diffract. And to remember how to draw the diffraction patterns for waves passing around an obstacle and through a gap. Nice straight lines, a nice consistent wavelength, and a little curve showing the wave diffracting into the gap. I hope you've found this video useful. Please like and subscribe, and I'll catch you next time. Cheerio!